Hello and welcome to the final session, the key points, the key ideas, the summary points that we have discussed throughout the video presentations in this symmetry and group theory in chemistry. I hope you might have enjoyed the entire journey. I am your instructor, Saurabh Muktibod. So let's start. Point number one. A symmetry element is a point, line, or plane with respect to which a symmetry operation is performed. Point number two, it says that a symmetry operation is an arbitrary movement which leaves an object looking the same after it has been carried out. What does it mean? That the operation that produces a superimposable configuration. Point number three, that states that a point group is a group of symmetry operations that leaves at least one common point unchanged, which implies that they may be given certain symbols, and the symbols used for assigning a point group are known as Schonflies symbols. As you might have been familiar with these terms in our earlier discussion, and the point is that we need to talk about the group theory and therefore the group multiplication table that states that each row and each column in the group multiplication table lists each of the group elements once and only once. From this, it follows that no two elements in a row or a column may be identical. When we are going to apply the group theory to the symmetry elements in operation, we are trying to understand that a group theory is a branch of abstract algebra which has a certain combination of rules which can be applied to a generic body. When we're talking about a representation, we generally mean by a matrix representation, and that matrix representation contains an information that is coded in the form of a symmetry operation, which can have a basis for the set upon the representation acts. So a representation is a matrix that brings about the transformation of the basis under the operation X. The basis is the set on which the representation acts. A character in a character table denoted by chi is the sum of the diagonal elements of a matrix representation, may be reducible or irreducible one. And the next point, a character table is a collection of characters of different irreducible representations present in that point group. Also, in a reducible representation, all the matrices have block diagonal form. An irreducible representation cannot be reduced further. Recall that you have something known as similarity transformation technique. Using that technique, it is possible to block diagonalize the element and get an irreducible component out of it. The next point states that a reducible representation of a group can be converted into irreducible representation by suitable similarity transformation. It is possible to determine nature and number of irreducible representation by using the standard deduction formula, which we have discussed, that a reducible representation can be represented in the form of the sum of the irreducible representation of a particular point group. Symmetry species are the labels of irreducible representation of a group that is found in point number 12. Point number 13 states that decomposition of direct product is the reduction of a product of symmetry species to a sum of symmetry species like tau into tau dash is equal to tau 1 plus tau 2 plus and so on. That is, there are certain rules in which we can have a direct product of representations based on it. The next point states that for an integral of type f1 and f2 d tau, there are two functions in f1 and f2 d tau. To be non-zero, the integrate f1 and f2 must have the symmetry species a1 that spans to a1, or that must have the symmetry species a1 or its equivalent type like a dash, a1 dash, ag and so on in the specific molecular point group, and otherwise the matrix would fall or the integral would fall to 0. So this is a necessary condition for a non-zero matrix. The other point states a symmetry adopted linear combination is a combination of atomic orbitals adapted to the symmetry of the molecule and used as the building blocks for linear combination of atomic molecular orbitals. Now that is a key point in the Huckel's theory. That's Huckel's molecular orbital theory, which is generally used for conjugated aromatic patterns in deciding aromatic behavior of certain molecules. When you're talking about SILE, or symmetry adopted linear combination, it helps in reducing the labor involved in complex quantum mechanical calculations, and therefore this is very important when you are using it for reducing the complexity of problem that we undertake for its solution. Allowed and forbidden spectroscopic transitions can be identified by considering the symmetric criteria for non-vanishing of the transition moment between the initial and the final states. Now, again recall that it must have the A1 symmetric species, just we have seen in the integration of product of two functions, integration of f1, f2, d tau in the entire space has to be a non-zero integral for which spans on A. If we wish to decide about the polarity of a molecule, to be a polar, a molecule must belong to Cn or Cnv or Cs. That is, it should not have a higher symmetry. Generally, symmetric molecules tend to have a zero dipole moment or a dipole moment which is close to zero because of their structural symmetry. It also implies that if the molecule may be chiral, then it does not possess an axis of improper rotation, Sn. This is also an important condition. A molecule may be chiral only if it does not possess an axis of improper rotation, that is Sn. For predicting Raman and IR activity of molecular vibrations of a particular molecule of a particular point group, we use a system where each atom is to be decomposed into 3x3 order of matrix for obtaining a reducible basis, because if we are interested in recording the vibrations for each atom in a molecule, then each atom has to be seen in a 3x3 Cartesian coordinate system. So if we talk about water molecule, then water molecule have, because there are three atoms, so we believe that it would have a 9x9 order matrix. And for benzene, when there are C6H6 structure, there are 12 atoms. So we believe that 36 into 36 order of matrix would be required. Obviously, that is tedious. However, we have a shortcut method that accounts for contribution of character of unshifted atoms, and also for a molecular vibration to be observed in IR region, it must change the dipole moment of the molecule. The dipole moment vectors have the same symmetric properties as the Cartesian coordinates x, y, and z. Similarly, if we wish to talk about Raman activity, for molecular vibrations to be observed in Raman spectra, there must be a change in the polarizability of the molecule, and the polarizability has the same symmetry properties as the quadratic functions or the binary products that we see in the last extreme right part of the character table, that is x, y, y, z, x, z, x square, y square, z square, x square minus y square, etc. So these are some key ideas that you might like to revise. And since you will be going for the quick test or solution making program, then you will be obviously requiring these key points. Thanks for watching. Now I ask you to relax, enjoy, and have a good cup of tea for the day. Thanks again.